Welcome back to another series of the Number Prime Production. In this episode, we will talk about the subgroup and lattice diagram. But for those who visit this channel as a first-timer, remember that I am yours truly, the producer, Mr. Brian Carey Palmares. Without further ado, let's talk about the objectives of this series. By the end of this series, you will be able to understand the foundation of subgroups, theorems, lemma, and corollary, and also understand the lattice diagram to visualize subgroup structures. You must also enjoy the satisfaction of learning and solving problems, and lastly, achieve a good score in assessment and future exams. In preceding episode, you will encounter this key term, and you must note or pause the video so that you can internalize it. You must note the induced operation, order, Hasse diagram, theorem, corollary, remark, and lemma. In this series, we will be discussing subgroup definition, different types of subgroup, the subgroup test, cyclic subgroup definition and structure, lattice diagram construction, the Lagrange theorem in lattice diagram, and the fundamental structure of lattice diagram. In sets, we have a subset, but in group, we have also a subgroup. In the formal definition of a subgroup, if a set H of a group G is closed under the binary operation of G, and if H with the induced operation from G itself a group, then H is a subgroup of G. To further analyze this, let's use some visualization. Here, you have a group G under operation star, and you have a set H which is a subset of G, and it turns out to be a subgroup of G if and only if H is closed under the operation of G and they have both the same operation, which is star. Again, we must take note that H be a subset of a group G, closed under the binary operation of G, and H with induced operation from G, and we can call H a subgroup of G. Let's take a look in this example. Let us consider H, which is an integer multiple of 10 under the operation addition, be a subgroup of G, which is an integer multiple of 5 under the operation of addition. Is 10z is a subgroup of 5z? What do you think of it? Remember the condition 1 that 10z must be a subset of 5z. Obviously, 10z must consist a multiple of 10, and 5z obviously consists a multiple of 5. In the diagram, 10z elements are inside in the 5z elements because for some 10z consists 5z. Hence, 10z is a subset of 5z. The second condition must satisfy that 10z must be closed under addition. Let 10a plus 10b be the element of 10z, then 10a plus 10b is equal to 10 times quantity of a plus b. Since a plus b will equal to something, and that is c, which is an element of integer, then 10c must be element of 10z because any value of c will give a multiple of 10. And so, 10z is closed. The third condition is that 10z must induce operation from 5z. As you can see, same operation in both groups and therefore, condition satisfied. To summarize, this three condition is satisfied. Therefore, 10z is a subgroup of 5z. For non-example, consider the group S is a set of 1/2 raised to n such that n is an element of integer under the operation multiplication, and a group V which contain a rational closed interval from 0 to 1 under multiplication. Can we say that S a subgroup? So, let's check if it is a subset of V. Since n can be any integer, then we let n be equal to negative 1. Then 1 half raised to negative 1 will result by raising 1 and 2 by negative 1 because of by power rule. And further simplification will result to 2. But 2 is not an element of rational with closed interval from 0 to 1. Obviously, therefore, S is not a subgroup of V. Now, you understand the true definition of a subgroup. What are your thoughts? Leave a comment and suggestion for our channel, The Number Prime Production.